Hi, this is the lecture overview of section 5.3 of the rational functions. This is the actual second part of this topic. The first part we stuck with finding the domain and the domain and the asymptotes, but on this one we are sketching the graphs. And I created a little mnemonic device to help us remember what are the things we have to do to sketch these type of graphs. And remember, when we were doing the polynomials and all these other graphs that we had already completed this throughout the course, when you sketch a graph, remember what that is doing. You're finding the solutions. So every point on the graph are solutions to the function at hand. So when we were doing the quadratic functions, and you had to find the vertex, and you had to find all these other additional points, and you sketched the graph, and you sketched that parabola represented the solutions to that particular function that you were actually doing at the time. Well, now we're going to be doing the same thing, but just on a much higher level. So we're graphing these types of functions. And if you notice, I got three examples up here. This one's a linear over linear, linear over quadratic, and then two quadratics being divided by each other. So there are three different ones. But every one of these graphs have to have the same routine to follow. And like I said, I created a little mnemonic device to remind us what we have to do. Now, in class, we'll have a whole lot more time than I do here in this little 5 or 10 minute lecture here. This one right here, we'll talk about. This one we'll talk about. This one we'll talk about. This one we'll talk about, especially that last problem. And the obliques we won't talk about in this one because it's not really talked about in the course at all. I do because I like to be complete about this. But oblique asymptotes we won't really discuss here. So if you want to see those, you definitely have to come to class for those. And we also talk about the holes, if we have them, or they're also called the removable discontinuities. So now, every one of these topics you have to do, you have to go through a checklist. Have I found the x-intercepts? Have I found the y-intercepts? Have I found the horizontal asymptotes? Have I found the vertical asymptotes? And if you can say yes, 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 all those questions, you should be done with the graph by then. So the first function is f of x equals 3x minus 6 over x plus 2. So the first thing you do is you go through the x, and y-intercepts. Now to find the x-intercepts, like we did in class, to find the x-intercepts, you set the numerator equal to 0. So 3x minus 6 equal to 0. So set the numerator. That does the first one. So top 1, top 1. So 3x minus 6, x equals 2. So it's 2, 0. So that is the x-intercept. Now the y-intercept is set all the x's equal to 0. So 3 times 0, 0 plus 2, so it's going to be negative 6 divided by 2, which is negative 3. So 0, negative 3 is the y-intercept. Now, see this x-intercept right here at 2, 0? Kobe still applies here. So since 3x minus 6 to the first, so the graph will cross there, which is going to be helpful. So especially when you start tracing the graph. Now the next part is the horizontal asymptote. Like we talked about in the 5.2 section, this is 3x minus 6 over x plus 2. These degrees are the same, so it's the ratio of their coefficients. So 3x, 1x, so it's 3 over 1, which is 3. So the horizontal asymptote is 3. So the graph actually will get close to this horizontal line at both extremes. So, and then the next thing is the vertical asymptotes. And we talked about that in another section as well. We found vertical asymptotes by setting the denominator equal to 0. And so that's x plus 2, so x equals negative 2. So there's a vertical asymptote right through there. All right? So that's what we got. So this is what I call the skeleton so far. When you get to the I have a part, you should have the skeleton pretty much complete. Now the rest of it is just fill in everything else. But one thing you do have to do is determine where it crosses the horizontal asymptote. If it does, it may not cross it at all. And how you determine that is you set the function on the C part, you set the function part 3x minus 6 over x plus 2, set that equal to the horizontal asymptote. In this case, it's y equals 3. And you solve it. And if you get an answer, that's where it crosses it. If you don't get an answer, that just means it doesn't cross it. And you're like, well, how do you not get an answer? Well, check this one out. You don't get an answer for this one. You'll get 3x minus 6 equals 3x plus 6. So you move the x plus 2 to this side, and you get 3x plus 6. The 3x cancels, and 3x cancels, and you get negative 6 equals a positive 6. which is an untrue statement. So you don't get a value of x. And you're like, well, what's the point of doing this if they're not going to give you an answer anyway? They don't always do, because they don't always cross it. And you're going to come over here, we're going to do this problem in a minute, and you're going to find out it actually does cross it. So this one does not cross the horizontal asymptote. Now, like I said, we're not going to do oblique asymptotes at all. So right now, this is just sitting there as a filler, and we're going to do that one in class. We'll talk about that one in class. But you're ready to trace the graph, believe it or not. So since you got 2 points on the graph already, they got to be connected. So it goes through this point and it crosses that. So that's the graph has got to do something like that. And remember, we don't care about the exactness of it. We just want the shape to be the same. So remember what I said, what it does to horizontal asymptotes? The graph actually gets really close to this. So it does that. It goes underneath it. And you're like, well, how do you know it doesn't go above it and come back down? Well, because it doesn't cross the horizontal asymptote. That's why we did the C. So it stays below it. It doesn't cross it. So it's kind of like a ceiling, if you will. So, and then it goes through here. Now, the graph really has a choice. It can go either up or down, but not both. You got to figure out which one it is. Well, if it goes up, it has to get close to the vertical asymptote. But if it does that, it would have to cross here between -2 and 0. But there are no x-intercepts between -2 and 0. So it can't cross there. So this part is out. So the graph actually does continually on its way down. Now that's not the complete graph, that's half of the graph. So this is the graph that's on the left side of -2. Well, what about the right side of -2? Because remember, the domain is all real numbers except for -2. So there's a part on the other side as well. So yeah, it's either this part or this part. What do you think it is? Is this one up here, or is it this one down here? Yeah, can you do a test point? You can. You can do a test point. You could test -3 and see if it's up here or down here, which one it is, and see what it is. But I guarantee you'll get a number up here. And the reason I know that is because if there was a point down here, it would have to do this right here. If it does that, it would have to cross the x-axis somewhere on the left side of -2. But since I don't have any x-intercepts on the left side of -2, it kind of forces the graph's hand to be up here. Now, I will tell you this. You're going to find out a lot of the times on these vertical asymptotes, if on one side it's negative, on the other side it's going to be positive. It ended negative, and it will start positive on the other side. And that's going to happen every single time when the degree on the bottom is odd. You remember Kobe on the x-intercepts? Crosses. He went from negative to positive, positive to negative. Okay? The vertical asymptotes work the same way. So if it's got an odd degree, it goes from negative to positive, or positive to negative. Just on the extremes. Instead of being really close to each other, it's on the other opposite sides. Now, if that was an x plus 2 squared, and you're not going to see very many of those, then the vertical asymptote, one side will be negative and the other side will be the same. Or one side will be positive and the other side will be the same. You do not see those. Maybe 1 out of 50 problems, you'll see one of those. So most of the ones that you're going to see, one will end negative and one will start positive on the other side. Now, the next problem, very similar. So this is the graph. And you're like, well, that kind of got a little wave in it. Does it really have that wave in it? Probably not. Remember what I said a while ago, though, it's kind of, I just want the shape. So, all right, now let's do this one. First thing off is the x-intercept. So that's the top, that's the top. So set the top equal to 0. So x minus 2 equals 0, so x equals 2. And it crosses again. That's very important. And then the y-intercept set the x is equal to 0, so 0, 0, 0. So it's -2 over -4, which is 1/2. Okay, so I is done. Now the next thing is the horizontal asymptote. Now we talked about these in the 5.2 section. When this one's degree 1, this one's degree 2. Do you remember what the horizontal asymptote when the top is smaller than the bottom? If you said y equals 0, you are correct. So it levels off on the x-axis. Now, the vertical asymptote is, you got to set the denominator equal to 0, just like we did back in 5.2. So if you set the denominator equal to 0, we have x squared minus 3x minus 4 equal to 0. X minus 4 times x plus 1 equals 0. So there's a vertical asymptote at x equals 4. And there's a vertical asymptote at x equals -1. And what that tells us is that the graph will not, it's like a wall there. The graph cannot cross the 4 and it cannot cross at -1. Okay? So now does it cross the horizontal axis? This is kind of like asking a very obvious question. Does it cross the horizontal asymptote? Well, it obviously does because the horizontal asymptote is the x-axis and you have an x-intercept at 2. So you kind of got it, you know that it does. But let's say you're very mechanical and you don't really pay attention to such things. How would you do it? Well, you would do it the same way we did it here. We set the function equal to the horizontal asymptote. So to do the c, you would set x minus 2 over x squared minus 3x minus 4 equal to the horizontal asymptote, and the horizontal asymptote is 0. So you move the denominator to the other side, which happens to still be x minus 2 equals 0 because this times 0 is still 0. So sure enough, it's x equals 2. But you're kind of reinventing the wheel on that one if you do it that way. The oblique asymptote, not going to worry about this one. We're ready to trace. So you remember how I kind of put these 2 points together a while ago? I'm going to put these 2 points together using Kobe. It crosses down to the other side. Now this part here can go up or it can go down. Which one do you think it's going to do? Yep, it goes up. And you're like, well, why can't it go down? Because if it goes down, it runs flat in this x-intercept, this x-axis right here. There's no x-intercept between -1 and 0. So it kind of forces it to go up because there's no doorway there, if you will. Here, it can either go up or go down. It can't go up because there's no x-intercept between 2 and 4. So it just continues its downward spiral there. But it ended negative, and these are all odd degrees down here. X minus 4 to the first, x plus 1 to the first. So if it ended negative on one side, Kobe is going to say, well, it's got to start positive on the other side. So it does this. And I'm running out of the room a little bit there. That's kind of what it looks like. Not done. I still got on the left side of -1 to worry about. So what do you think? Well, it ended positive, so it will start negative on the other side. And you know all this stuff that I'm saying, well, ends positive, start negative. You're like, well, how can I remember that stuff? Well, and the beauty of this is you don't really have to memorize that part of it. You can just test points. You could test -2 and put -2 back in, and you would end up that would be a negative number down here somewhere. And then you plot that point, and then you got it. Then it forces it to be down there. So you can always do test points. I have found students who do that messes it up most of the time simply because they mess up on the simple calculations. It's like a storybook. You just kind of follow what's going on instead of trying to add extra stuff in there. So, and it's a lot easier if you do it that way, to me. But some students will say, no, that's not true. I like to do it by plotting, testing points. And I don't have a problem with that as long as you do it correctly. So, and then the last example, okay, x plus 3 times x minus 3 on top, and then 2x squared plus 3x plus 1 factors to 2x plus 1 times x plus 1 on bottom. So this one's going to be a little more lengthier. So now the x-intercepts is set the numerator equal to 0. So plus or minus 3. And then the y-intercepts is set all the x's equal to 0. So it's 0, 0, 0. So it's -9 over 1. So it's -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Down here, way down here. Okay. Now, horizontal asymptote, what do you think? Well, the degrees are the same. X squared, 2x squared. So when that happens, what do you think? It's 1/2, isn't it? Because the leading coefficients are 1 and 2, 1 over 2. So it levels off right through the 0 and the 1. So that's the I have the I have part. Then I got to do the vertical asymptote, and the vertical asymptote will be really close together. One's going to be at 2x plus 1, so it's going to be at -1/2. And 1 is going to be at -1. Now, I wanted to show you this one because I wanted to show you what happens when the vertical asymptotes are really, really close together. The graph becomes almost unreadable. So you almost have to make it really big, but you got to know that kind of beforehand. So So we got this going on. Now, does it cross the horizontal asymptote? Well, you would have to set the function x squared minus 9 over 2x squared plus 3x plus 1 equal to the horizontal asymptote, which is 1/2. And if you cross multiply, you get 2x squared minus 18. You multiply this way, and you go the other way, it's 2x squared plus 3x plus 1. And the 2x squares cancel, and you get 3x equals negative 19. And trying to hurry this up a little bit, you get x equals negative 6 1/3. So that tells you the location of where it actually crosses the horizontal asymptote. So I will probably need to extend this out a little bit further than what I've got going on here. So negative 1, 2, 3, 4, 5, 6. So it's about right there. Don't have to be exact, but I have to be pretty close. So about right there is where it crosses the horizontal asymptote. So if you notice, I did it on every one of these problems. I set the function equal to the horizontal asymptote. Didn't get me anywhere on this one. Okay, it got me to an obvious answer on this one, and it got me to a surprising answer on this one. So now, are you ready to go with it? I think so. Do the same thing we did here. Connect those points. If it goes up, it runs into a wall, so it's got a continuous downward spiral. And then it goes and levels off on this side. It ends negative, so just on the other side of this vertical asymptote, it will start positive. But since there is no crossing, the graph is kind of sandwiched between these two vertical asymptotes. So it's kind of like a parabola shape. You're like, well, how low does it go? I don't really care, as long as it doesn't cross the horizontal asymptote. So it has this shape right here. It's very tight in between these two vertical asymptotes. And then since it ended positive, it will start negative on this side. And notice there is a hole right there in a good position for me to go through, because that's the x-intercept. Then it goes up to this extra crossing. Now, instead of the graph continually going up, like you would think it might, it can't do that, because if the graph continues up, it doesn't approach your horizontal asymptote, which it must. So what it does, yeah, it goes across it, but it just kind of comes back down and flattens back down on the horizontal asymptote from the top side instead of the bottom side. So these crossing things are not that important, especially in this regard, but because the shape wouldn't change much unless your graph is going above it or below it. So some teachers don't even teach the crossing at all. I do. So, but anyway, this is the shape, and like I said, I mean, this is kind of sandwiched in there between. They're really pretty tight, and this is sometimes going to happen for you, and so you're going to have to kind of learn to spread out your x coordinates a little wider, so you're more or less zooming in. So, but that's 5.3. I know it's lengthy, and I apologize, but it takes a while to do these. Like I said, this is probably one of the harder sections in this course, so it requires a little bit more of our attention. So I hope it helped, though.